I'm sure you must have enjoyed the previous session, interaction session, which I had with Professor Jaichander, and you could have seen what research areas he is into and what are the problems on which he is working, what are the various projects he is handling. Now today, in today's interaction session, this particular session, I am taking you to his lab. We will go and see what are the research facilities created there under his mentorship in IIT Gandhinagar. So, in IIT Gandhinagar, we have this under mechanical engineering department, there are some research facilities, and as you know, Professor Jaichander is working in the domain of heat transfer. So, we will go and see the research facilities created by Professor Jaichander in IIT Gandhinagar, and also will interact with his research scholars, PhD students, master students and postdoctorate fellows, and we will see what kind of work areas they are working in. Those of you who are related somewhere to this particular domain, they can always think of your career in that direction, and you can always think of working with Professor Jaichander in future. So let's go and visit the lab.
Desalination technology. So we have equipment related to different kinds of desalination technologies. So for example, this is a setup that can be used for membrane distillation as well as forward osmosis. So primarily the purpose of this setup is to quantify membrane performance. So like try to identify how much is the membrane permeability at different temperatures, test different kinds of membranes at different pHs. This is the idea. Again, it's used for thermal desalination and membrane characterization.
Okay. So this is one of the main equipment we have in the lab.
This is just used for the membrane characterization. Once we have characterized different membranes, then we build systems using that, and those we'll see subsequently. So this is a setup that we have fabricated, my students have fabricated. It's like a multi-purpose system for testing different kinds of osmosis based membranes. So as you can see, it's pretty heavy and sturdy because we want to test up to 70 bar at least, very high pressures, because we are working with reverse osmosis as well as other kinds of membranes. So the particular membranes that we test here are reverse osmosis, nanofiltration, ultrafiltration, forward osmosis, and particularly it's counter flow reverse osmosis that I told you. So the design is such that you can have flow on both sides of the membrane, salt water flow on both sides of the membrane.
So how do we generate that high pressure?
So the high pressure is generated by this motor, which is connected to a high pressure pump at the bottom. The pressure level is set using this back pressure regulator. The back pressure regulator is controlled by this device, which we can supply an electric input 4 to 20 milliamperes, and that will help us set the required pressure. The pressure finally is coming from that high pressure nitrogen tank. So yeah, we have instrumentation to measure flow rate, pressure at different locations. That's broadly the idea. The other pump that you see is for the draw solution. So if you have high pressure water on one side, you have low pressure water flowing on the other side. So we have another pump for that. We have 2 tanks for the 2 solutions and level sensors to measure like how much time it takes for the water to flow. So yeah, primarily this is like membrane characterization as well as testing new technologies like this counter flow reverse osmosis.
So these are the 2 main test rigs which we are using as of now for this, right?
Right. Thereafter, we have another test rig here. This is an electro dialysis setup. So this is electrically powered, where positive and negative ions are being removed from a solution through membranes that are selectively permeable to positive ions and negative ions. By putting them alternatively, one set of solutions become purified and another set becomes concentrated. So this is the technology. Again, we can control the applied voltage, control the flow rate at which the process is performed, change different kinds of membranes, the anionic membrane, cationic membrane. This is the idea. And finally, we have one more setup here. So this is a multi-effect distillation system. So basically, a thermally powered desalination process, where we are coming up with a new design to try to make it more energy efficient, more compact for high salinity water treatment using thermal energy. So here we are using an electrical heater to demonstrate this in the lab scale. But going forward, the heat supply will primarily be some kind of waste heat source like low pressure steam or solar energy. So those are some of the experimental setups that we did.
Professor, I think quite impressive, and I interacted with you and what were you explaining. Now I think I can make some feel of this, I can understand this. Wonderful things, and we are also in the process of developing some more test rigs in the future. So what is
if I ask you future development plans for you for this particular lab?
So in this lab, it is more about I think scale up. So right now what we have is small scale devices that can help characterize system performance. But device development at a larger scale will be part of the idea. The other thing is that while the main membrane characterization tests happen here, we would have to use the central instrumentation facility to like actually characterize membranes after use. So those things we do in a central facility rather than those. So I would say more like system development.
So what I feel is like this space will look like limited in future, So
Yes,
are you
already we are.
Yeah, you're feeling that.
But we have to make best use of the space that we have, and then eventually we'll end up.
Perfect, and thanks a lot, Professor Jay, for this small visit to your lab. And I'm very sure whatever you have explained that will be very useful to us. Thanks a lot. Okay, so let's start our interaction with the PhD scholars here and postdoctoral fellows here in this lab in IIT Gandhinagar. So thanks a lot to all of you for giving your precious time to YourPedia team here. So first I will request you to tell आपका नाम, your name, and the place and which course you are in this IIT Gandhinagar. So one by one from you.
My name is Vijayender and I am from Electrode and currently I am working as a geologist fellow in IIT Gandhinagar.
And you have also completed your master's here.
Yeah, I did my master's from IIT Gandhinagar in 2020 and after that I joined as a geologist. I have an offer for PhD on the
Okay, I'm looking for it.
So I'm waiting for the visa.
So you are in the process of going and then till then you are doing here. अच्छा अहमद what domain you are working? Which area? कौन से domain में आप काम करते हैं? Research. ये जितने भी टेस्ट स्ट्रिप पड़े हुए हैं is something
I'm
about
working on the design and development of multi-effect computer discussion system.
that is a primary domain.
Yes, okay. So I am trying to optimize the system and actually the main idea of this work is to develop an energy efficient system. So we are
Energy efficient system.
trying to keep changing the design so that we can get good performance.
तो अभी आप PhD भी उसी domain में करना चाह रहे हैं?
Yes, not exactly the same, but it will be around close
तो
to
ये बोल सकते हैं कि आपका काम desalination से related है. Your work is related to desalination also. Can you say that? Forward.
Myself Arjun, I'm a research associate.
Okay.
I joined this lab 2 months back. So after my PhD in meticulous. So where I have been working on my remaining, that's a multi-effect design system, permanent design system. So now I'm also part of this new group, which is looking into the membrane distillation for the process. So I'm also involved in research activities. Also, I'm trying to explore other areas of design.
So your domain of work is also the same, right?
Yes, desalination.
Desalination. And you already completed your PhD and now you are going for postdoc.
Yes.
Postdoc. So any specific project on which you are working on, particular problem on which you are working?
So it's based on a proposal that myself and Professor Jaichander has implemented. So that one of the area will be this immunity system, and then we will be looking into other aspects of RO membranes and which will be doing in this future.
Okay, Arjun, looks like you have quite experience in this particular domain. I'll ask you a very straight question. Like student is prepared for MTech, looking for a research problem in this particular domain, desalination or energy efficiency domain. Can you suggest him very straight what problem we should work on? You know, their students are confused like what area we should work on in graduation or post-graduation. Anything you can suggest.
Suggestion of any problem to work on episode will be defeating the purpose of research. So it is all about we have to find
Identifying the problem.
identifying the problem and then try to solve it. So it's not just like
Somebody should tell you and then
it's not the right way of research. Research involves like initial
So,
steps of
Arjun,
research.
let me put my question a little differently. Research should be based upon solving some problem which is existing presently either with the industries or the society. So do we see some problems? Like okay, there is a need to work on this particular area. We have desalination problem. Potable water is not there. Then plants are we need to create a lot of desalination plants in India because because we are not having potable water, that the fresh water problem is coming. So any problem which you can tell students, okay, this is the real problem, it's not really something to work on that.
Distillation is an area which is being pursued worldwide by many institutions, university institutions that are doing it. So we are also part of that. But see, it's not just about this. We all know that there is a larger issue of having scarcity of potable water, and should be solved for the existence of essential for the existence of humanity. But then it's about trying people and then finding out, okay, what area can we work on based on how can we. Basically, the questions will be always how to reduce the price of water. How can you reduce the impact of desalination on the environment? So these are some of the questions that currently being discussed by different researchers. So I think students can find searching out research on this area, and if they find suitable technique, okay, that they can pursue with their background, then they will be able to choose.
Yes, perfect. Thanks a lot, Arjun, for your points.
Myself, Rishabh. I am from IISc UK. I am a second year PhD student. I am working on this validated modern distillation system. So my work is both experimental and numerical modeling. So currently I am modeling the MEMD system like this system. So with that result, we can match how much, like we cannot repeat our experiment again and again. So we want to develop a numerical model also, so that we can see that how close we can reach in the real environment. So that will be pretty benefit to us.
Okay, so Rishabh, we will come back to you little later कि आप इस setup पे काम कर रहे हो, simulation के लिए क्या चीज़ की requirement होगी, and I will also request each one of you to tell us little later that if some student looks for joining PhD course in Premium Institute like Gandhinagar, so what preliminary knowledge we should have? You just use the word simulation. BTech level students are not even focusing on that, so they hesitate, with the words like simulation, programming, optimization, the use of MATLAB also students do not know. So मैं आपसे straight थोड़ी देर में पूछूंगा. In fact, Vishal sir, please ask these questions also. Like Rishabh will be showing this test rig and then asking कि simulation में क्या requirement है. मतलब बच्चे को क्या पता होगा simulation. And Rishabh, you joined it after BTech or MTech? After MTech. You know that many students are joining now PhD after BTech also. So answer with that perspective in mind that okay, BTech वाले बच्चे को अगर PhD join करना है तो क्या उसके पास knowledge होना चाहिए शुरू में, so that once he lands up in this institutes like IIT Gandhinagar, so he can make justification with that research work. Over to you.
My name is Siraj. I am from Gandhinagar. I am a PhD student. My main work is related to desalination using electrodialysis and using CFR.
So this one, right?
Yeah, this one and this one. So they are from main topic.
तो अभी कितना टाइम होगा चिराग आपको?
I have completed 2 years.
2 years ago. So you also joined after MTech?
Yes, I have joined after.
Okay. तो अभी ये recently you have created this facility?
Yeah, it's like around 6 months there.
6 months back. Okay. So I think now Vishal sir, you can take a look at each facility and maybe like Chirag explains about ag research, also Jay has explained Rishabh, this is the so only that part which is worth sharing, which you want to share, you can please share it with us so that it helps whosoever sees it, who's will again need details of that. Focus should be on okay, we are doing this, why we are doing this. ऐसा नहीं कि सब एक सेटअप हमने क्रिएट कर लिया, दिखाने के लिए पेपर रिसर्च पब्लिश करने के लिए. Focus should be when I do this, what are the anywhere from Gujarat, entrepreneurial state of India. So we would like to ask you like what are the entrepreneurial options. आपको धंधा स्टार्ट करना है, इसको कैसे किया जा सकता है? So business opportunities related to your job, right? उसमें कहाँ से होता है? Each one of you like desalination or if you can land up in some venture, create my own facility and this direction and then the opportunity like you go for. You like to help in that direction. So from where we should start? From whose work we should start? Explanation of the testing and then idea. So you only got it, yeah? Over to you.
Very today we are with Chirag and second year PhD student. He is going to tell us what exactly what he is carrying out in this particular lab. Desalination, some work related to desalination he is carrying out. and where is the future scope? Like how we can use this facility to create some kind of, you can say, entrepreneurial, or you can say some problem. Okay, how we can industrialize this particular concept. Okay, so over to you, Chirag.
Yes. So this is a electrodialysis setup. So it will work using electricity. So in case of RO, we are pressurizing the water. So that water will pass through the membrane and we are getting water. So in the case of electrodialysis, instead of pushing that water, we are removing the salt. So that is the basic difference between reverse osmosis and electrodialysis. So using electrodialysis, we are removing the salt. So in terms of entrepreneurship, currently most of the work of electrodialysis is on brackish water. So in the case of brackish water, if we go for a higher plant, then the cost of producing that pure water will be lesser in longer duration. So that is the area currently electrodialysis is focused
You know,
on.
RO technology is very much conventional and fully established,
Yeah.
we can say. So how this particular technology can compete with
Yeah.
that particular technology?
So based on that question, I will have to answer that electrodialysis was found earlier than RO.
Okay.
Yeah, but the main problem with electrodialysis is currently the cost of that membrane is very high. So it's like only few companies are manufacturing that membrane. So the cost is driving that product. So in case of RO, lots of
Post is fine. Post, I think we can relate it with mass production. So we not consider this kind of post. What do you think? Performance-wise, this this system is
yes competitive compared to RO. So in case of RO, if we are comparing only energy wise, so energy wise this electrodialysis can beat reverse osmosis up to like 20 to 25 gram per liter. So
and what about the life like suppose
Life,
RO system we need to replace those kind of
Yes.
internal system after
Yes.
1 year.
So in case of electrodialysis, life will be very high. So in case of if we go for industrial, very large desalination plant, it has like around 10 to 15 years, but this can have 15
So
to
you are carrying out major work in the improvement of performance of this electrode.
yeah, optimization as well as cost wise analysis.
So, Jaichander sir told us that there is some kind of comparative analysis also. Like what are the different water purification system are there, like desalination is there, electrodialysis is also purification, RO is also there. So, what do you think? Which one is best for the performance wise?
So best we can answer based on the feed. So feed is having different salinity and what our product we want. So in product what salt we want to have. Depending on that we can choose which technology will be the best.
So, Chirag, what do you think? If some student wants to work in this particular area, what kind of basic knowledge or prior knowledge is required?
Basic knowledge is like like thermodynamics, heat transfer. That thing will be I
So,
think
all
prerequisite.
mechanical engineering student, they can comfortably handle it.
Yes, all mechanical,
It is more
chemical.
chemical.
Yeah.
I think this domain is more related to chemical or mechanical or both?
Yeah, it is a combine of both.
Combined. You are
I know
mechanical,
mechanical.
you are mechanical. So you all are like the student, most of the students are from mechanical only.
Yes, most of ours mechanical. Some earlier JRF was from chemical.
Chemical.
Also. So it's like interdisciplinary work.
Okay. So you do have this infrastructure facility here. So guys, we talked with Chirag. So this was the facility. We are with Rishabh. He is going to tell us multi-effect membrane distillation system. How the system is different from a conventional RO system and counter flow RO system. And there is a future scope in the system and what type of research he is doing in this particular area. So what do you Rishabh? And first of all, thank you very much for sparing your time to discuss with us. Please.
So, multi-effect membrane distillation of salt any is different from RO in the sense that it works on the thermal principle. Like RO is basically pressured
turbine. This is more of the thermal turbine. There is it is like a passive system like in RO we require pumps to create high power pressure. Here we don't require that much of pressure. We can just make simple pump we can feed the water. And mostly we provided a heating element within the sea here to generate a temperature. And in that temperature is used to evaporate the water and the water is collected through the membrane. So this is the
Actually, I'm not directly involved in this type of area, but I'm also in some kind of basic thermal background. If you ask me a simple thing, when we are converting, we are utilizing electric energy to get some kind of pressurized energy, we are converting higher energy to higher energy because pressure energy, the potential is also kind of higher energy, kinetic energy. But when we are converting some kind of higher energy electricity into thermal energy, yes, we are generating energy. So how we can make that system compatible with those kind of system where the entropy generation is less? I think the entropy generation is less if you are going to RO system, and that's the reason behind that system is more efficient as compared to those thermal system.
so like in previously thermal system there is a lot of waste like you said that there is a entropy generation.
Yes.
During generation there is an entropy generation.
Yes.
So the main advantage of this multi-effect in the main is that it utilizes the heat of the previous now. Whatever heat is lost is utilizing
Okay,
that.
means it will be good if you utilizing the waste like the vapor absorption system. Basically, compared with VCRs, we will say that the performance is low. But when we are utilizing the waste heat, like it will be solar, it will be the waste heat from the industry, then it means we are extracting the energy available in that waste to carry on this distillation. Okay, so thermally driven system, what again? There is a future scope, and what research actually you are carrying out in this? Like, I think the concept is very much old because thermally regeneration is a thing which we are using from you can say centuries.
So the main objective of our study is to like in the domestic we are generally using RO system to purify
Yes.
water. So and this thermally driven desalination system works at the industrial level. So the main objective is to like commercialize it and it can be used as a domestic purpose. Like next, and we can compare its phenomenon with the RO, how it is doing. And other advantage is that, like I said, there is like it is a very passive system. There is no like active pump or that kind of risk required.
What I think, I'm not very much sure about this, but those people who actually work in this area, desalination, using solar energy or waste energy, I found the water production, the water purification rate we can say, it is very low as compared to the RO system which we are generally use.
So like that is also our main objective to like improve its efficiency. Currently, the like single effect single effect membrane installation have like efficiency or that this system we use GOR, like it is a equivalent of COP we can say if you want to compare. So like GOR is basically less than 1. So we want better the GOR, the better is the performance. So main objective of this system is to improve the GOR or thermal efficiency so that it can be used.
So it's a kind of what like how actually are
Yes, it is a kind of what basically what we do in
detection device for carrying out that research means you attach some kind of heating to the system.
This is the heating element. The one element is there. That this is like we can use cooling water also or expose it to the ambient. The rest is happening.
So is this a wastage of the system? I think there is an advantage. What I believe is on this thermal system as compared to RO. In RO, I think we need to use some kind of water. So but is there any wastage?
Like this problem may be there, but we can overcome it. Otherwise, like there is no wastage. Like we can in this system we can also use the whatever the brine like high concentrated this thermal we can use that also because
This high concentrated brine is not like that.
no means like we can use that high concentrated as a feed also like we can purify it because in the RO there is a limitation on the like membrane that up to particular salinity we can operate. Here we can go above beyond that RO that one.
So my last question is to you. If you ask you how, like, a thermal engineer, we are having also a background MTech in thermal engineering. So, what actually, how you are proceeding in this direction to improve the performance of this system, thermal system? Yes, so, we are working on this heat exchanger, conversion process.
Yeah, I did conversion in my masters. I have done this in the waste heat energy recovery process, so I got my interest from there. And this like same principle is like for different application using the same principle. Like we are doing the dissemination.
So, what temperature we are maintaining in this limit?
We are like we are giving 70 degrees centigrade for 30 per line. And we are giving the feed up to
So it's nice talking to you, Rishabh. It's there your time. And we discussed, practically it is a very good student. They are getting exposure without wasting, in this present scenario, if you are getting information, we are interacting with student. And yes, they can think what are the researches are going on and what program, like you can easily, you can say explore what further you can explore in that particular area. So if someone is interested to carry out research in dissemination, so what I can say is this IIT Gandhinagar is the best place. The infrastructure facility here available in this lab are excellent. So lots of people are working here. So thank you very much. So there is another system which is known as CFRO, a counter flow reverse osmosis system. So I will request Chirag to just tell us some basics about this particular system, how this system is different from conventional RO system, and where is the future scope, and what type of research he is doing in this particular area. So over to Chirag.
So compared to conventional RO system, we have developed CFR. So in case of conventional RO, you can go up to like 69 bar. After that, membrane will grow. So in this setup, what we will do, we are supplying our feed solution using this high pressure pump. And on the other side also we are supplying feed solution, which is also having certain salinity using low pressure. So because of that, pressure difference will be required will be lesser. So using that, we can get desired salinity solution using this setup. That is the main idea of developing this setup.
So where you got the idea of this working on this particular project? Means you developed this particular facility, or that was available from some kind of industrial scope?
No, it is developed by one JRF which was working here, Vijayender. So he developed himself.
Is that kind of facility, that kind of scope you are having at IIT Gandhinagar? And you can procure any equipment which is required for carrying out research?
Yes, he has buy this thing and designed by himself and developed that CFR.
Different parts means...
yeah, he has procured different parts and assembled so that it will work fine. That is
so what thing, how like performance basis, what do you think, how the system is efficient? That you mentioned, it is more suitable if there is a high salinity in water.
Yeah.
But if you use with normal salinity, what do you think? With normal RO and this counter flow reverse RO system, what is
so we can use this as a normal RO also, but what is the main problem that currently desalination plant are increasing. So after that seawater RO, brine is having around 70 to 80 gram per liter salinity. That is added into the sea. So we can use that high salinity brine and use that high salinity brine inside the CFRO. We can also get pure water from that high salinity water also.
If I will request to tell some kind of research data, like suppose 1 liter water production using high salinity water, like because that is a main requirement. Pure water requirement is needed. That is a need of future also. And high salinity water is abundance, it is available in the sea. So what is the cost of generating, you can say, 1 liter pure water using this particular system? Is there any that kind of literature is available?
I don't come across that type of literature till now. But yeah, currently seawater data is available. So using seawater, it will vary around like 0.6 to $1.2 per meter cube. $2 per meter cube.
Okay, so where is the future scope of this system? But just some of the points you can highlight. What are the further future development we should take, which can be carried out in this particular area?
So first result will be the membrane. So currently membrane is having 3 layers. So that out of first layer is active layer, then there is a support layer. So in the case of CFRO, we have to develop a membrane that can specifically design for this setup. Because currently membrane is available, but it is available mainly for seawater RO and brackish water RO. So that's one of the topic of this. Another is optimization of this setup.
So main system is that membrane.
Yeah.
How you are developing that particular for this CFRO system?
Currently here we are not synthesizing that currently. So that will be one of the research.
Which we are procuring to.
Yeah, currently we are procuring.
Available in India or outside of India?
No, company is available.
Company is available.
But it is like US company.
Yes. So what do you think? There is a cost here. What's the cost to that membrane? And what's the life?
Currently the cost of if we buy 40-40 membrane, which is having like 40 inch length and 40 inch diameter, so it is costing around 27,000 to 30,000. Life depends on how you are using this, up to which pressure you are working in, what is the fouling, all that will affect the life temperature.
So thank you, great interacting with you. You are some major basic functioning of this particular equipment, and yes, it will be good for most of the students. They will watch this particular video. It is going to help because finding a problem and working on that, and there is a very much problem which is related to our let's say society. So working on a problem which is going to help masses, that is a good thing. So my best of luck to you and your team also. So you will be able to succeed in your goal. Thank you.